I'd like to open up by asking each of you to give us an opening statement of, where you think things are at, what you feel is going on at this moment that you would like people in the United States and the rest of the world to know in terms of, is this a big deal? Is this not such a big deal? Is it urgent? What's the thing that you've got that you want people to know that they might not be reading in the New York Post and the Wall Street Journal and Fox News? And what are you certain of that you feel you want to let them know? I do want to just also say, before we get started, that Mark Maslin's a climatologist. Guy McPherson is a professor emeritus from University of Arizona. And although they both speak about the environment, Guy does take a much, much more extreme approach. Let's not use the word extreme. Let's just say a different approach, that he feels the situation is, considerably more dire and urgent than what Mark has spoken about. So just want to point that out, that even though we all speaking on the same subject, there are different points of view. So if you guys could each open up with your opening comments on this subject matter.
Shall I go first?
Great.
I'm Guy McPherson. I'm conservation biologist and professor emeritus at the University of Arizona. I can distinctly remember being 10 years old, which is pretty damned impressive at my age, and hearing my parents talk with other teachers. They were teachers in the public school system. And I can distinctly remember them having this conversation with these other teachers. They were saying, if we don't fix fill in the blank environmental issue, if we don't fix deforestation, if we don't fix water pollution, if we don't fix the myriad predicaments we were facing at that time, within a few years, we're going to be in real trouble. That was 46 years ago. I think we're in real trouble on multiple fronts. I think mostly we don't have problems, we have predicaments. Problems have solutions. Math books have problems, they have solutions at the back. Predicaments don't have solutions. Predicaments have, for example, there's no politically appropriate strategy to dealing with climate change. So I think we're beyond the point of being in a problem. We're in a series of predicaments, and we're in real trouble.
Oh, got this. Okay. I'm double mic'd. Hi, I'm Brian Richter, and I apologize. I do have a little bit of a trailing laryngitis, which I'm working very hard to get rid of. But basically, I play two roles in my professional life. One is, my primary role is I have led the Global Water Program of the Nature Conservancy for the last couple of decades and remain the chief scientist of that program. And then I also teach at the University of Virginia, teach a couple of classes in water there. I think it's really interesting that Guy started where he did in reflecting back on what kind of dialogue was taking place, when we were kids. So I was thinking about the exact same thing on the plane flight down here today, and I was thinking about in elementary school, middle school, high school, that in our biology classes, you would hear both the information that was available at the time and the forecast, the predictions. And the two that I remember most distinctly were the one about population, and there was that sort of exponential growth curve, and they talked about the population getting to 7 billion or 8 billion at that time, and we just thought that was sort of almost beyond the imagination, but still it was, that's what the scientific community was telling us at the time. And then the other part was, that I very distinctly remember, is they would talk about these psychology experiments where in the lab, psychologists would put a bunch of lab rats together in a cage, and once they got overcrowded, that they would start doing all these abnormal behaviors would start to emerge. And as I was reflecting on that today, I realized that not all of those projections have come true, but as Guy suggests, a lot of them have. In other words, we're now living in a generation, we're now living in the age where a lot of the things that people said were going to happen 30 or 40 years ago are actually coming to roost. And in my area of water, that's very, very much the case. We may not be, openly attacking each other in competition for resources, and particularly for water, but those things are starting to emerge in a number of places around the world. So here's the status of, just to kick this off from my perspective, I work on water exclusively. And in particular in the last few years on water scarcity and water shortages. Where they're happening, why they're happening, what goes wrong when that, what are the bad things that happen. The good news part of the story is that for about 2/3 of the planet, people who are dependent upon rivers and lakes and groundwater aquifers, 2/3 of the planet is still in pretty good shape with respect to water quantity, the availability of water. We're using less than 10% of the renewable supplies. The other third is a completely different story. It's the stories that you hear about the Western United States, about Syria, about places in China, there's the Middle East in general. There's a third of the planet that's really grappling with water shortages. And it's something they live with every single day, or at least they live with it whenever the next drought comes along. And it's really, really serious. It's becoming more and more intense, and greater implications of not being able to generate electricity, not being able to grow food, not being able to have drinking water in many places. And so that's kind of where we are right now. My take on this, and as you'll hear in my lecture tomorrow, there is a silver lining to this, even in that 1/3 of the world that's in bad shape. And ironically, it comes from the fact that we use and manage water so poorly, we waste it so much that there's a lot of potential to turn this around in a hurry. But we have to start implementing some really sound practices in our daily lives and in our communities.
I'm Mark Maslin. I'm a climatologist. I'm a professor at University College London. And for me, over the last few years, I've become fascinated in looking at the wider issue of human impact. So for the last 25 years, many of us have worked on climate change, but this has actually obscured some of the other areas of environmental degradation that have been going on. And so what's interesting now is that the science community is actually coming to the conclusion that perhaps we, the human race, is actually a geological superpower, and we have actually moved the planet into a different geological epoch called the Anthropocene. And for this actually changes our philosophy, and it changes our viewpoint of ourselves. And so what I'm interested in is, now we've actually acknowledged our global footprint and how huge it is, what can we actually do to try and reduce or mitigate or change our effects? Now, when we talk about climate change, we have all the technology already invented to deal with climate change, to actually reduce our carbon emissions. What we lack is, of course, the political will, the economic systems. But if we look through history teaches us that we have crises every so often in human civilization. After the Second World War, it was obvious that the peace had to be formed that was actually for the greater good of the world. And they had 10 years planning, and they brought out things like the United Nations, the World Bank, the IMF, all of which were formed at the Bretton Woods Conference and formed the basis of the increase in wealth and changes that occurred from the 50s onwards. However, that had its own consequences, which is, of course, fossil fuels, climate change, and a lot of environmental degradation. So now we're in the 21st century, we need to reinvent a global civilization and international organizations again, so we can then rise to the challenges of the 21st century, and perhaps this time ensure that we actually look after all the people, not just, as I talked about this morning, the 1%ers.
Thanks. I'm Jerry Pollack, and I'm a professor at the University of Washington. I feel somewhat removed from this discussion because I have not been involved with climate change. In a sense, I'm an outsider, but I'm indirectly involved with climate because climate involves water, and we study water. We study the fundamental science of water. And we discovered what we believe is a fourth phase of water. We all understand that water has three phases, a solid, liquid, and vapor, but we found the fourth phase that actually has been hypothesized for 100 years, and we found evidence for it. So my particular, or any particular contribution to this discussion will have to do with what makes climate rather than what makes climate change. And you'd think that a knowledge of climate or weather would be the fundamental understanding that would be a necessary condition for understanding changes of climate, because we don't understand climate. For example, it is a simple consideration that you have a cloud, and the cloud consists of little droplets of water, and these droplets all have charge. They all have the same charge, negative charge. And you'd think that if all these little droplets had the same charge, they would repel each other and you'd never get a cloud. So a question is, why do you get a cloud? And we think we understand that, but it's not obvious to people, and clouds are so obviously central to anything that we know about climate, about weather. Another, you look up and you see a cloud, and you ask yourself, what keeps the cloud up in the sky? I don't know if you ever thought about that question, but clouds consist of water, little droplets of water stuck together somehow, and these droplets of water are heavier than air. They should be pulled down by gravitation. It ought to be raining on your head all the time, and it doesn't. Sometimes it does, sometimes it doesn't. So what keeps the cloud up in the sky? And then, if the cloud is up in the sky, how come sometimes the water comes down and sometimes it doesn't? You see, we live in Seattle, and Seattle has a lot of gray skies, and you don't know sometimes if that cloud is going to unleash that water or not unleash that water. And when it does unleash the water, the odd thing is that it doesn't just drop down to the earth. Some measurements of the velocity with which the rain falls have demonstrated that you can calculate. If you have a body and it free falls, you can calculate the velocity with which it'll fall. But real measurements show that the rain falls up to 10 times faster than what you can calculate. So something is actually pulling the droplets to the earth. So these are questions not about climate change, but about climate. And I think unless you know something about climate, it's hard to talk. You can certainly talk about the political issues and ramifications of climate change, but it's interesting, I think, to understand climate first.
So for people who are watching this and are still on the fence, is there any credible organization or scientist anywhere at this point that are not acknowledging that we are dealing with climate change and the effects of it? Is there any credible scientist anywhere that are making a logical case that this is not happening?
I'd like to comment on that. So I'm outside the field. However, a lot of scientists come to me because they know of our interest in water. And I must admit, I've heard cogent arguments on both sides as to how much we are actually contributing to the issue of climate change. And I kind of sit as an outsider. And this is so tinged with political influence that it's really hard to pick out what's true and what's not true. This is the voice from the outside. And I don't necessarily name names, but I've heard cogent arguments on both sides, and I think there's some legitimacy to the propositions, at least that I've heard from both sides.
I have to say I find that quite a strange point of view to have as a scientist. As a scientist, I understand the scientific method, I understand how weight of evidence is actually produced, I understand how you've gone through your experiments to actually show. So what I find quite odd is then you are quite happy to not believe other scientists who have spent 35 years studying climate change, doing it in the labs, studying how clouds work, how they actually do warm and cool the planet, how we actually have experiments to show that greenhouse gases absorb heat when they're actually in the atmosphere. So I find it quite odd, and actually usually it's not people such as yourself, chemists, and people looking at the physical world, but it's usually engineers I find are the most skeptical, going, no, I don't believe this science. Because science is a rational methodology. And so when you have methodologies that actually clearly state and show you evidence, and a weight of evidence that things are actually happening, and that the greenhouse gases are warming the atmosphere, I find it then difficult to see why any of the skeptical views can actually be accepted. And if you think about it, this is not just one or two scientists saying, you must look at my research. This is the whole world. This is research scientists in every country who are actually working on this subject. They are putting it together in the Intergovernmental Climate Change reports, which occur every 5 years. Now, I don't get paid by anybody else apart from the university. And trust me, if I could prove that climate change, with evidence, was not true, I would be a Nobel Prize winner. I would have my face on Time magazine, and the Republican Party would pay me for the next 100 years, okay? So before you say, you're all motivated to show the same thing, you're in the pockets, etc. No. I am a deeply competitive person. All my friends and colleagues are. We're scientists. We're competing with each other for the best ideas. And over 35 years, we still come out with the same result, which is greenhouse gases that we are emitting are causing warming in the atmosphere, which are causing climate change. And in the future, we know from the politics that the amount of greenhouse gases going into the atmosphere are going to increase. And we can calculate from simple physics what that's going to do to the atmosphere, and then we can make predictions about what it's going to do to the hydrosphere, which Brian's looking at. We can look at the oceans and how they're warming up, and then we can look at things like sea level and how that's going to change. So I think it's worrying that we have very smart, very clearly dedicated scientists who don't actually think that climate change may be happening.
Oh, let me just clarify. The issue wasn't whether climate change is happening. The issue is to what extent we contribute to the change. Obviously, climate change has happened again and again and again over the eons, and there seems to be evidence it's happening more rapidly now than it's happened. But I just want to say that for me, I myself don't have the time to look deeply. There's so much evidence out there, and evidence from both sides and from serious people, someone from Harvard University, for example, who spent many years working on this and has an opposite point of view. I've been involved in science in many fields, and I've come to appreciate that the majority view is not always the correct view. The majority view in many areas is challenged, and a very organization that we run called the Institute for Venture Science is in business to provide funding for those people who have reason to challenge the prevailing point of view. So the fact that the authority of many scientists suggest one point of view, and a minority of scientists point to another, doesn't necessarily mean that the majority is correct. I remember it was Lord Kelvin who said, "Nothing can fly, nothing heavier than air could fly." Now, Lord Kelvin was a famous scientist, and I think he was wrong on that, and almost everybody thought he was right about it, but I flew here from Seattle, so, so that's my only point, not that I myself, who have no experience, no authority, no reason to say anything about climate change. It's just that I want to point out that there are serious scientists who believe that the evidence suggests otherwise, that it's not necessarily us and the carbon emissions that are the principal cause. That's all. I'm not prepared to argue for or against, only that it's a very complicated story because you're presented with two sides, and just because the majority believes one doesn't necessarily convince me that the majority is absolutely correct. That's all.
Okay,
outside.
Well, I am now deeply worried because you kept using the word believe. Okay, the scientists that study climate change do not believe in climate change, okay? It's not a belief system. You're a scientist, okay? You should be there actually looking at the evidence. So do you believe the fourth phase of water? No, of course not, okay? You're looking at the evidence. Same with climate change. It is about weight of evidence. It is about clear testing hypotheses again and again and again. And we've tested these hypotheses over the last 35 years. So I find it quite galling that you come in and say, well, it's a balanced view. Actually, there's arguments on both sides. That's a climate skeptic's argument, okay? This means that we should have a false balance in the press. We should always have a climate skeptic paid by the fossil fuel industry versus a climate scientist who spent the whole life dedicated to studying climate change. Is that what you want? I am sorry. I mean, I'm shocked. I thought I was here with a bunch of clear, rational scientists, and you've now decided that actually no. We can take alternative views, and that's fine if a random scientist suddenly believes, which you use that word, believes that climate change is not happening. We should accept them.
Please be clear. It's not that, I'm sorry if I use the word believe, but obviously I'm talking about people who claim they have evidence in the other direction. And I'm not prepared, as an outsider, I'm not an insider, I don't know the experiments that you and other people have done. However, as an outsider, I'm not prepared to dismiss a dissenter's point of view based on evidence. I don't know, but I have no authority because this is not my field. I'm just expressing from the outside an appreciation that there is another point of view. That's all. I don't know which point of view is right because in order to decide which evidence is most convincing, one would have to spend a lifetime. I don't have a lifetime to spend. I'm doing other things. That's really all I meant to say. I hope you're correct. I don't know if you are.
Yeah, Mark, let me just, I just want to jump in here and say that I emphatically agree with Mark. I think that the media has in part misweighed, given the impression that this argument is actually still a debate, because they'll, for the sake of news and sensationalism, they will always put somebody on the news channel that, says no when the other one's saying yes. And I don't discount, Jerry, your point about the naysayers, the heretics, sometimes have been right in history, and that's always a possibility. But I also think that as a society and in terms of governing ourselves and deciding about the things that we should do or not do, the things that we should support or not support, I believe very strongly in the weight of evidence. The weight of evidence on this is overwhelming. It's 1,000 to 1, maybe 10,000 to 1. I mean, it's not even close. And so, while, we can always, point to a number of cases where, there was a preponderance of evidence and somebody who was saying no turned out to be right in the long run. I think that, the only sensible way for us to act to move forward is to take the weight of, as Mark said, scientists that have spent their careers and have accumulated a tremendous volume of evidence, and it's irrefutable evidence in my mind at this point.
Yeah, I want to follow up. We often hear about the 97% of scientists who believe climate change is driven by humans. But what we almost never hear about is the actual publications, the refereed journal literature, which is incredibly conservative. And I'm going to have to try to come up with something from memory, so the numbers won't be exactly correct. I don't remember if it was 2012 or 2013, the last time I saw information on this topic, indicating that there were 12,000 and some papers published in that year, that calendar year, 2012 or 2013. And of those 12,000 and some, there were 2 or 3 papers that concluded that there was no anthropogenic climate change. So that's way, way more than the 97% of the individuals. It's 99.9% of the published science indicates that climate change is driven by humans. I think this is it's a done deal at this point, and I think people who claim otherwise are trying to make money or appear in the media or trying to sow the seeds of doubt, as the film The Merchants of Doubt just indicated, that just came out within the last year or so.
Okay, so there are some people that say, yeah, so we have climate change, that's disappointing, there'll be less almonds and it'll be a little hotter. They're not understanding the connection of what you're saying. So what are the implications of climate change? In other words, for a person who lives in the United States in an affluent area where they have a lot of good things, they drive a car, they go to the supermarket, there's water, there's food, everything's good. What are the implications? Because even when California has a water shortage, they still have water. It hasn't actually happened where they've run out of water. So what is the actual potential implications if, that would affect regular life in the United States from continued ignoring of climate change? What are the things that would affect people? What would be? What would it be?
Well, I'll start on the water point, Steve, since you alluded to that. You said in California there's still water, even though there's climate change and drought taking place. In truth, every drop of water that runs across the surface in California is being fully consumed unless there's a very, very strict enforceable law saying that you can't take any more, like the Endangered Species Act, for example. In truth, what California has done over the last few years has gone and raided the savings account of the water that's stored beneath the surface of the earth, groundwater aquifers. They have very, very rapidly depleted their aquifers in trying to make up for the fact that their need for water, their demand for water, is higher than what the rivers can provide, what that annually renewable, replenishable water supply can provide. Now, in terms of just, some of the consequences, I alluded to them before, but this is really coming to bear in when you end up in that situation where there's too much competition for the available water supply, somebody ends up coming up short. And it's not always predictable as to which sector or which individuals or which companies are going to end up being short, but it is having effects on just about all of the things that we depend upon in our lives. It is having a big effect on crop production. We're having massive decreases in crop production, agriculture production, which is sending off price spikes that are affecting a lot of the poor economic members of our society, and especially in other countries. And that's one example. There are places where, because we don't have enough water to generate electricity, they're having rolling blackouts. There's some cities like Addis Ababa in Ethiopia where, on average 4 days a week, there is no electricity available to them. And it's largely because they don't, oftentimes it's because they don't have enough water to run their power plants, to run their hydroelectric power dams, and that sort of thing. So these are really, really very real consequences, and they're affecting lives, they're affecting local economies, and they're affecting natural ecosystems. Because we're taking so much water out of those sources, we're leaving the plants and animals that depend upon wet places, wetlands and rivers and lakes, we're really compromising them as well. And so we're seeing a lot of species disappear as a result of this as well.
If you look at the US, because it's so large, unfortunately you get all the effects of climate change. So we've talked about the droughts in California, but of course in August we had huge floods in Louisiana. And we know from sort of NOAA's study that these floods in Louisiana are going to be twice as likely in the future. And the problem with floods is the flood water doesn't go, oh, no, I'm not coming here because that's a rich neighborhood. I'm just going to the poor neighborhood, okay? The water will go where the water goes. So the problem is it affects everybody. And we also have, again, in the US, you have, of course, storms rolling in, you have hurricanes, and we know that over the last, say, 4 decades, the storm intensity and the numbers have started to creep up. Now, again, what's interesting there is actually the biggest problem is not the increase in storms, It is the change in society. And this is what Roger Pilk Jr. talks about, which is what happens in America is that you work hard, you have very small holidays, you put all that money aside, and you retire. And then you decide you're going somewhere nice. So you move to Florida, you have a coastal property, and you live the retired life you want to, right in Hurricane Alley. So what we're doing is, over the last 4 or 5 decades, not only are storms increasing, but we're moving to the places which are at risk because they have fantastic coastlines, and that's where we want to live. And so again, sometimes society and climate change are starting to clash. And again, we need to think these things through. Look at Hurricane Sandy hitting New York. Now, we know that hurricanes quite regularly hit New York. One of the real problems with geography, and I am in a geography department, is I can tell you, and this is unfortunate, which is hurricanes hit the Gulf of Mexico. They hit the Florida coast and the Carolinas. They don't hit Washington, okay? Just because of the quirk of how the turn of the country, no hurricane has ever hit Washington. They just pass by and hit New York, okay? So unfortunately, you have put your capital where it's safest, which is most unfortunate, because I reckon if you get one good hurricane in Washington, lots of the things about climate change would change very, very quickly.
Maybe Brian can talk a little bit about saltwater intrusion. A really, really minor increase in sea level rise has great impacts in terms of drinking water in places like, Miami Beach. Can you talk about
Right. Right, yeah, thanks, Guy. So this idea of saltwater intrusion is that on the coastal areas where you have underground water, it's sort of the underground water, the underground fresh water and the ocean water are sort of, pushing at each other and in fact keeping each other largely at bay. But there are two things going on that are affecting that sort of dynamic equilibrium of push and pull between salt water and fresh water. But let me start by saying this is important that tension exists and that the fresh water is able to resist the salt water from coming in because we depend upon that fresh water. We stick groundwater wells down in it and we rely upon it for our water supply. So thank goodness there is some physics and chemistry going on that keeps those two bodies of water separate from each other. But that balance is getting changed because of two things. One is that we're pulling groundwater out of the aquifers faster than it can be naturally replenished, so already that level's going down. And then salt level, the ocean level, is rising. And so what that change in that relationship causes is for the salt water to move inland. And as it moves inland, it starts to cause what were once freshwater aquifers to become salty. And they become too salty to drink really quickly. I think I saw the statistic or the story recently that it's like a tablespoon of salt in a bathtub can make it unpalatable to drink. I mean, it's something on that kind of order. It's remarkable how little salt it takes to contaminate a freshwater source and make it undrinkable, unpalatable. So we have to be really, really mindful of that changing, and because of those two factors, we're seeing that unfortunately happen, that a lot of groundwater wells are now having to be abandoned, once freshwater wells having to be abandoned because the salt is intruding, the ocean water is intruding into what was once fresh water.
And this really matters from an adaptation perspective. Miami Beach, which is a pretty wealthy neighborhood, is, as I understand it, changing their building codes to require higher ceilings, thinking that when sea level rises, they'll just pour an extra 3 feet of floor with concrete and be up above the sea level rise. Well, they're completely ignoring the two most important factors about sea level rise: storms, storm surge, and saltwater intrusion into the freshwater system. So if you don't have any water to drink, I don't care how big the stilts on your house, you're still not going to be happy.
Are the wildfires that I see on the news connected to climate change? The wildfires, I believe we're seeing bigger wildfires out west. Is that connected to climate change?
Yeah, I've written a couple of books about wildland fire, and it's pretty obvious that the increased acreage burned of wildfires and the intensity of wildfires are both related to climate change. You know, there's this 2015, the United States saw the most acres ever burned in recorded history. And I haven't seen the statistics for 2016. And also, Fort McMurray, right in the heart of the tar sands, was evacuated. The entire community was evacuated because of a big wildfire. And everything I read by climate scientists indicate that that fire was as big and catastrophic as it was because of climate change. So this shouldn't be a big surprise. This is one of the self-reinforcing feedback loops I talked about in my presentation earlier today. As it gets warmer and drier in the interior of continents, you get bigger and more fires, more ignition, more wood consumed, more wood turned into carbon dioxide into the atmosphere, which makes it warmer and drier in the interior of large continents.
And of course, then we also have the compounding effect of what's happening with the forests themselves and becoming weaker and more vulnerable under climate change. And so a lot of the forests, these trees adapt over long periods of time. You know, you see different species of trees moving into different areas as the climate would have historically or naturally, prehistorically, changed more gradually. But it's changing so quickly now that these trees are really in a stress condition, in a sort of a weakened condition, and you end up with a lot of die-off of the trees just because of that, and that creates, of course, a lot of fuel, a lot of dead wood that's available to make the fires a lot worse. That's getting compounded by the fact that various predatory insects, bark beetles and that sort of thing, are able to take advantage now of those weakened trees under the climate change. In fact, some of these insects are able to move into areas because there's no longer the coldness or the climate phenomena that would have kept them at bay. So now you've got a lot more insects moving into these forests and doing a lot more damage to the trees, which just compounds all the effects that Guy just mentioned and really sets them up for some catastrophic wildfires.
How are the oceans doing, and how is climate change affecting the oceans? And does it matter?
Of course it matters. So I should start off that because I have done oceanography. So 2 things to kick off with the oceans. One, they're heating up, and unlike the atmospheric temperature records, which are quite noisy because, of course, we have different effects on the atmosphere, and, of course, it reacts quite quickly, the oceans heating up is a very smooth line and actually quite scary because it just shows you that 70% of the world's surface, which is about 3.5 kilometers deep, is just a hot reserve of water that's just heating up more and more. So the first thing is, of course, sea level rise, which we've talked about because of that thermal expansion. There's also additional water being added through the melting of Antarctica and Greenland, which at the moment is quite small contribution. It's mainly thermal expansion, but will get a lot larger in the future. So that's the first thing about the oceans. The second thing is that colleagues of mine, and this is where science sometimes can actually throw up things and you go, why didn't I think of that? Of course, we all realize that when you have CO2 in the atmosphere, it combines with water, and you sometimes get quite acid sort of water, which can damage buildings. Of course, what we forgot was, of course, that CO2 is also dissolved into the ocean. And so the ocean is actually getting more acidic. And people have referred to ocean acidification as climate change's evil twin. Scientists like to sell things, okay, to sort of like give you a bit of a sort of a fear factor. But at the moment, the changes are actually quite small. But as we burn more fossil fuels and put more CO2 in the atmosphere, the acidification of the ocean will increase. And the big problem is that, unlike on the land, where we are very adapted to quite large ranges of acid, okay, we have skin to protect us, in the ocean, when many of the actual organisms have calcium carbonate shells, They haven't experienced for the last 55 million years any major change in acidification, so they haven't adapted to it. So we're worried about coral reefs and being dissolved by this acidification. We're also worried about the small plankton, which actually is the base of the food chain in the whole of the oceans. And so at the moment, we're doing huge amounts of study to try and see how sensitive is the ocean to these changes. So those are the two things I would worry about the oceans. Aren't I cheerful?
Let me just follow up on that. A couple of things. We're in the midst, or perhaps near the end, of the third worldwide coral bleaching event
Yeah.
since 1998, and also the third one in recorded history. Think about that for a minute. 3 worldwide coral bleaching events in history, and they've all occurred within the last 20 years. With respect to plankton, the base of the marine food web, and therefore the source of half of the food humans eat, many areas of the ocean have lost 30% of the plankton. And according to the incredibly conservative Referee Journal literature, the entire ocean system is on the brink, because of changes in pH and temperature, of losing all the plankton. At 6 degrees Celsius above baseline, it's difficult to imagine that we would have any plankton at all. So that's kind of a big deal for those of us who like to eat.
When we go to the store, it's got more food than ever before. The health food supermarkets are loaded with fruits from around the world. It's very hard for people to really take to heart that climate change could cause food shortages, especially in the developed world. What's your perspective of how close are we possibly to having any type of food shortages because of climate change? Is that something you consider a real and present threat, or is that something you consider far into the future?
I'm happy to start. So let me just say something real quickly about water shortages and why they come about. They're really the result of a supply and demand problem. So anytime your demand or your consumption of something, your personal bank account, your withdrawals, once they get to be as large as the deposits, you've got a serious problem. And so there are some crops like tomatoes and rice and a number of other really, really common foods that we eat that are currently being produced in places that have serious water shortage problems. Okay? Another way to make that point is that about 20% of all of our food is being grown using water from groundwater aquifers that are rapidly declining. So so at least, if you can just start out, 20% of our food production is unsustainable under current practices. And a lot of the rest of it is vulnerable. It doesn't mean that they go out of production every year, but we're getting these repeated shocks. Every time there's a little bit less water available, a little bit less supply, the agricultural demand isn't being satisfied, and so you have a shock. So every time we get these, what a drought does, the media likes to say that droughts cause water shortages or that droughts cause water crises. They're not looking at that equation, at the balance. Yes, it's causing less supply to be available, but it's the fact that our demand is so great that makes us so vulnerable.
You asked the question, I'm going to follow on from Brian, about, say, the food in the US. Now, for me, food availability is about purchasing power. So the problem is that when we have these food shocks, so one of the classic ones was the huge heat wave that occurred in 2010 in Moscow. It's called the Moscow heat wave, but it affected most of northern Russia. And that affected their wheat, and therefore they banned the export of wheat to try and protect their wheat for their own country. That had a huge knock-on effect to other countries who were used to importing wheat. Now, in the US and Europe, if our bread goes up by 60%, you might whine about it, you might complain about it, but actually it is not a huge cost. Your food is a relatively small percentage of your sort of weekly sort of outgoings. Whereas in many countries, most of the money that people earn goes directly on food to feed themselves and their family. So a 60% increase in other countries is actually quite frightening. And so I think the problem is that we in the West will never really feel that sort of food shock, because again, we're able to actually buy the food which actually perhaps should be going elsewhere. And again, what we're doing is by opening up all the world trade is stopping countries from protecting their own food sources, because we want to sell food in there, but we also want to take their food and actually bring it to ourselves. So it's a really complicated problem, which is as climate change starts to really affect certain countries, if they don't have inherent wealth or historic wealth, they're going to have problems being able to buy in food to actually maintain their sort of like population.
So that brings to a question. This is actually something I would like to ask the panel, because I've raised it and I can't get a cogent response, and that is, you know, the rainfall may be diminished in one area, but in other areas it seems that there's a lot of rainfall, and the question is, if you integrate over the entire Earth the amount of rainfall per week or per month or whatever, is it constant or is it not constant? And I haven't been able to get an answer from people who I would have thought could provide that answer. I wonder if anybody knows the answer to that.
Okay, so when we've done climate models for the next 100 years, what we see is that there is perhaps a small drop in the total a small increase in the total rainfall, maybe about 1% over the whole planet, okay, which isn't really significant. What we see is that the rainfall is actually coming in shorter, more intense bursts. So we go from a situation of having perhaps more distributed rainfall during the year in areas around the world, and we go to more intense storms and rainfall, which again, interestingly enough, you have to adapt to, because you have to have different ways of storing that water. Again, as a child growing up in London and going on holidays in England, I can tell you that in the 70s, August was the wettest month in England, okay? I can remember dreadful holidays with grey, drizzly rain throughout the summer. Guess what? That doesn't happen anymore, because we've started to move to a more Mediterranean-type climate, so we're getting hotter, drier summers and wetter, warmer winters. So we're already moving to that seasonality. So again, no, the total water doesn't change that much, but the way it arrives and where it arrives changes. Now, if we were a completely connected society globally, and we went, oh, hang on, we now know that this area is too dry to make food or have wheat. We'll move it over to this place where we know water is available and freely available. We're going to plant wheat there and make sure it's distributed. We can do that. That would be fantastic. But we don't. We have a system of nation states, and we have different wealth levels. And so therefore, we have an incredibly complicated political viewpoint and landscape, which actually causes problems when we're trying to distribute food around the world.
I hear you. If I understood correctly, you're talking about models for the future. I'm just wondering if there's any evidence from the past of actual rainfall measurements that could speak to the question that I asked.
Right, so there were two studies published in Nature about 5 to 6 years ago, which I can dig out for you. And what they did was they actually took all the records of rainfall and showed that over the last 60 years, and it was only for the northern hemisphere, unfortunately, because the coverage isn't as good in the southern hemisphere. And what they showed was that the amount of intense rainfall events had increased markedly over the 60 years, even though the total rainfall hadn't actually changed that much.
Okay. And that's probably because there is the equilibrium between the moistening of the troposphere, where more than 90% of the water vapor is contained in the atmosphere. And water vapor is the single largest greenhouse gas, comprising more than 90% by volume of greenhouse gases. And so that equilibrium is reached within a matter of days between moistening of the troposphere and global average temperature. And the physics tells us that a 1 degree Celsius temperature rise of the planet leads to 7% more moisture in the troposphere. Warm air holds more water than cold air does. And that's one of the reasons we're getting these superstorms and brand new terminology invented, like rain bombs. You never heard of a rain bomb until the media brought it up this year. Right? There was no such thing. So we invent new terms to describe these phenomena that previously didn't exist, because there's more water in the atmosphere than there used to be, and what goes up must come down.
Don't you think the sun's activity has something to do with this?
Solar radiance has declined since the early 1980s. So the amount of incoming radiation has declined while global average temperature has increased.
So you're both right. So before anybody says that solar radiation doesn't affect climate, you will see that if you look at the temperature record for the last 150 years, it goes up, but you can see that there are beautiful decadal cycles in there which are related to things like the sunspot, the North Atlantic Oscillation. So there are variations, but when you actually strip those all out, those all average out, and actually the long-term trend, and again, people were saying, oh, we've got a hiatus in the warming. Yeah, 2015 was the warmest year on record. And actually, your guy's absolutely right. The solar radiation has been dropping off for the last 10 years. It will hit a minimum, and then it's going to come back up. And the problem is that we've been warming strongly for those years. And one of the fears that scientists have is, as the solar radiation comes back up to average, and the warming's going to actually increase markedly, because at the moment the sun's actually slightly helping us against our sort of like climate change.
So, Guy McPherson wrote a book called Going Dark, and his point of view is that we are on the verge of abrupt climate change with all the most negative consequences from it. When he says abrupt, he means abrupt. He is. I guess if you could, Guy, maybe give us a guideline on your time frame of when you think abrupt climate change is likely, and I was wondering if the rest of you could respond of what your thoughts are. I guess we all hope that Guy's thoughts or predictions are not accurate. We're hoping that they're not, because they're disturbing and scary, but I'd like to hear Guy's thoughts and what your thoughts about what he's saying.
It's pretty clear that we're in the midst of abrupt climate change. The temperature of the planet increased about 1 degree Celsius from 1750 to September of 2015, and then increased another 5 or 6 degrees Celsius in the next 4 months. Those are the good old days, back in February and March. Since then, every month, we've set a new temperature record for global average temperature. And we just found out that yesterday that in August, we did the same thing. So I would say we're in the midst of abrupt climate change now, and a phenomenon that has precedence in Earth history with, for example, a global average temperature rise of 5 degrees Celsius in 13 years based on sediment records, as reported in a paper in the Proceedings of the National Academy of Sciences in 2013. And beyond that, I'd just soon not get into where this leads. You can read, or you can view my presentation from earlier today on what the science indicates with respect to the loss of global dimming and the temperature rise locked in as a result of carbon dioxide in the atmosphere based on the 10-year lag in emissions and maximum heating and so forth.
I don't have a lot to contribute here, Steve. These guys know the data, a lot better than I do. All I'll share with you is that personally, my perspective on it has changed a lot in the last 10 years. 10 years ago, I heard all these climate guys talking about, how much the climate was going to change, what its implications were for rainfall and snowfall and evaporation in that, and I thought, all right, they're talking about 40-year, 50-year, 100-year time frames. In the meantime, there's a whole lot of other problems I got to deal with the way that people are using water. I will say that in the last 10 years, my perspective on that has changed quite a lot, and some of the records that we are seeing for things like the timing of when snowpacks in the Rocky Mountains start to melt off, which has huge implications for how much water becomes available downstream, when that water comes rushing off of the Rocky Mountains. It has a lot, and if a lot of that water is washing off earlier in the spring, there's not going to be as much water that's going to slowly still be coming off when you get into the dog days of summer during July and August and September. And so our rivers are starting to drop to levels that we haven't seen before, because all the same amount of water perhaps coming off in general, but it's coming off much earlier. And our systems of using water aren't adapted to that. And so my appreciation for it has certainly changed. We have it's a much more serious problem for all of us to grapple with than I even thought about 10 years ago.
So I'm not going to disagree with Guy or Brian. What I'm going to do is try and broaden it out. Yes, we should be very concerned about climate change. Yes, I'm excited that Paris actually brought 193 countries together, and actually we have an agreement that countries are going to try to reduce their carbon footprint. Again, the cynics among you might actually say, right, let's see whether it actually happens or not. But there is now an understanding at the international level and within politics of most countries that climate change is affecting the people. It is affecting what's happening. And what's exciting, I think, sometimes in the United States is sometimes other countries hear the rhetoric, sort of like with the Republicans going, we don't believe in climate change, we don't believe in climate change. But what they don't see, and I'm very lucky because I've worked so much with my colleagues in the US, is at the state level, many states, many governors realize this is an issue and are actually working very hard about this. Again, in the northeast of the country, there's a trading scheme to trade carbon dioxide. California has very strict rules and wants to actually cut their emissions by 80% by 2050. So you have lots of these incredible things going on at the state level that don't actually get heard at the international level. And unfortunately, all we hear is the negative views coming out. So I think there is room for optimism in the United States that climate change is being taken seriously. But I also want to broaden this out, that actually humans on the planet, it isn't just about climate change. The environmental degradation that we see is exacerbating the water conditions that sort of Brian's looking at. We have deforestation, which is causing dust bowls in many parts of the world. We also then have an overuse of fertilizers, nitrates, and things like that. And again, lots of pollutants. So I think that we need to actually take a long, hard look and say, okay, we all want to be middle class. We all want to have our sort of lifestyle. How do we actually do that, but at the same time be stewards of the planet and actually look after the environment, which at the end of the day provides us with clean air, unless you happen to be in certain cities in China or in Los Angeles, clean drinking water, okay, and the food that we survive on, okay? So again, we forget this. We're in this bubble of, I would say, TV and gadgets. We don't actually realize that the three most important things, clean air, clean water, and food, all are reliant on our environment, which we're actually starting to affect in a very severe way.
Mm.
Well, with the rise, the predicted extreme rise in temperature, it's true that most species that ever existed are now extinct. Maybe our time has come. We hope not. But in terms of you're suggesting to take a long, hard look, I think the long, hard look should include also an understanding of what the climate is all about and what are the underlying features. I was shocked to find out, I was on an interview program together with a climatologist, and he told me during this interview that the scientists who were considering weather there are two things they don't understand, and one is clouds and the other is evaporation. And I was shocked because you'd think that somebody who is interested in this subject and doing this professionally would know very well. But in fact, it's not known. The physicists don't understand. And for example is, I gave you a few examples a moment ago, but even evaporation. So all of us are taught that, if you have a glass of water and evaporation is occurring, some molecules near the surface get a kick of potential energy or kinetic energy, and they rise up, and that's what evaporation is all about. And it's easy. We learned that. We think that. But the observations seem to go against that, and you can see that just by going to your local Starbucks and having a cup of hot coffee, right? You see the vapor rising from the coffee itself. If you've got a dark background like black, you can see the vapor rising. Well, it's known that if you can see the vapor must consist of little droplets, and they have to be bigger than the wavelength of light. So the wavelength of light is about half a micron, and people have measured what's rising up, and it's actually 10 or 20 or 30 micron, tiny little droplets that are actually rising. So these droplets may contain something like 10 to the 10th molecules of water. That's what evaporates. We're taught that evaporation is one molecule of water at a time, but the observations directly contravene this understanding. So if we don't really understand the nature of evaporation, and we don't understand how the clouds form, trying to ameliorate the situation in some way, the situation which is getting progressively worse, obviously, is going to be difficult to do. And so my suggestion is, if we want to address this, one of the things we need to address is an understanding of what gives rise to the weather cycle that occurs. And we don't have that understanding.
That sounds like one of my grant applications. We need to do more research on this.
Just the idea of saying anything about that we want to do anything by 2050. Again, just back to Guy. In other words, I'm totally okay to have the theory that Guy McPherson is irresponsible, doesn't know what he's saying, he's crazy, he's off. That's what I'm hoping. But if he's accurate, he's saying very, very strong things about the urgency that even if you thought any part of it was accurate, it would suggest that as a society, we need to be 10 times more urgent than our most urgent possible action. Now, if you think that what he's saying is not accurate, then we could do do whatever, and we could work on solar and wind and everything. But if anyone thinks that what he's saying is even remotely close, then it sounds like we have to change society. It's not enough to say, let's get cars that get 50 miles an hour. It's kind of saying we've got to go way beyond that. So,
I'm in the room, right?
yeah.
I'm right here. And you're talking about it. Okay, I just wanted to...
Just talking about you behind your back.
So the interesting thing about climate change, and I know Guy has a more extreme view of how bad climate change is than I have. However, again, I have a more extreme view of climate change than you do, okay? Because
I'm neutral.
You're neutral. Oh dear. Well, that's bad. He's definitely gone in 10 years, okay? So the key thing is that if you really want to be hard-nosed about it, we can do it through the economics, okay? So the Stern report, so Lord Stern, who basically is a world-leading economist, basically wrote the definitive economics of climate change and then published it. And what he said was, look, if we leave climate change for the next sort of 10, 20 years, it's going to start to cost us a huge amount. We're talking about 20% of world GDP. Okay, that's 1/5 of every dollar that's raised in the world will have to actually go to trying to actually slow climate change, adapt to climate change. Whereas what he said is, if we do it now, actually it's only going to cost us 1 or 2% of world GDP. And actually, if you think about it, if we actually do some of the win-win solutions, and actually you get business involved, you get all the renewable business that take over from sort of the oil companies, so they start making money for your pensions. If you start building high-speed railways, which then make a profit from you instead of the actual airlines, guess what? The economy doesn't actually change, and you can still make lots of money and you still have people who are then happy and safe. So again, you can use the economics. I hate to do this because they're always wrong, but you can use the economic argument and say, look, it's much cheaper to do it now, to actually fix it now, than to try to cure the problem when it's gone way too far.
Yeah, and Steve, I think the big question is, I do think that culturally, as a society, we are changing our approach to this, our acknowledgement of it. We're starting to mobilize on some of the adaptation. Last week I was in Stockholm, Sweden, where they convene the World Water Week every year, and the opening plenary talk was given by the mayor of Stockholm, and she said, and I hadn't heard it before, that Stockholm will be completely fossil fuel free by 2040. So that's pretty far beyond what California is pledging to do, and going all the way, all in. We're going to be completely clear of fossil fuel by 2040. So as more information comes in and as we understand climate science better, I think we are starting to internalize it and change our behaviors. But the big question is our rate of change of our behaviors going to be fast enough to keep up with the rate of change of what's going on with the climate and all the associated environmental consequences of that?
And I'd also like to add that one of the key things is that some of the changes that we can make have fantastic health implications. So for example, if you get rid of coal power stations and you put wind turbines up, or you put solar panels up, or you do wave power, suddenly air pollution from that source disappears. If we all move to electric cars, no smog in LA. Suddenly health and people's health change markedly. If we again, Richard gave a fantastic talk at the beginning of this conference where he talked about sort of like meat and the huge amount of sort of like energy and fossil fuels that go into producing every kilogram of meat. So again, if we move to a more vegetable-based diet, doctors are ecstatic about this. The health of the nation will increase markedly. You're moving away from a heavy meat diet, which is then linked to colon cancers and things like that. So the medics I work with, sounds really strange, love climate change because it's driving things in the right direction to make people much healthier. So you can end up with cleaner air, cleaner water, and basically a more healthy diet just by dealing with climate change. Oh, and by the way, don't worry, you can still make money out of it because we still need energy, we just want it from a different source.
And by the way, we'll also take care of water shortages in a number of places as well. So, just of interest is the Central Valley of California, the Colorado River Basin of the Western United States, the Ogallala Aquifer that you hear about in the Midwestern part of the United States. The use of water in each of those places, more than half of it is going to producing animal feed.
A couple of points before we move on. Civilization is a heat engine. Period. We know this from the incredibly conservative refereed journal literature. Civilization itself is a heat engine. Solar panels increase the heat. Where do you think solar panels come from? Pixie dust? Takes a tremendous amount of fossil fuels to make solar panels. So civilization is a heat engine, and as long as the heat engine is going, we're going to continue to heat the planet. And secondly, it was 46 years ago that my parents were saying we need to change right now. My co-host on my radio show on the Progressive Radio Network, Mike Sleva, almost every episode says, yeah, but if we start right now, and it's a joke, because we needed to start right now 50 years ago. And every year has been worse than the year before in those last 50 years with respect to every aspect of the living planet, not with respect to smartphones.
So assuming that the next administration in the United States, the next president, and all leaders around the country say, okay, we're 100% in, we'll do whatever it takes, and you guys are in charge, and everyone will follow your exact instructions. And we'll do any solutions you propose to solve the environment, the water, the deforestation, the biodiversity, the ocean acidification, the coral reefs, the wildfires. They'll do whatever it takes. Richard Oppenlander was here the other day, and he said, absolutely no matter what, 100% give up eating animal products immediately, because to raise them and to grow the feed for them is contributing. So that was his idea, and it seemed very good. It seemed excellent. What are your suggestions? You're now in charge of the planet. You have full control, and your job is to stop this climate change and all these other problems. Assuming we'll all go along with whatever you say and we'll fund it, what should we do?
Okay, shall I start with that one then? So I would actually start with something quite simple, because I actually think that sometimes, and there's this wonderful book called Nudge, whereby you can just nudge people. So the first thing I do as world dictator, thank you, Steve, for my election, is then make subsidized fossil fuels illegal. So I would strip out globally all fossil fuel subsidies. Now that comes to about, according to the IMF, that well-known left-wing think tank, that it's about $5 trillion per year is spent by different countries subsidizing their fossil fuels. So if I did that, I would just strip that out. And the first thing that would happen is fossil fuels then become much more expensive. Actually, then renewables become more competitive, and actually, you're going to buy your electricity from renewable sources than fossil fuels. So that's the first very simple little tweak you can do that then starts to use the global capitalist system to actually drive things in the right direction. Now, that's my starting gambit. Who else is going to help?
I'll jump in, Mark. Again, I'm sort of a one-trick pony. I only talk about water. You know, a couple of observations of where governments and communities have tried to make change with respect to water. A couple of principles that I think have proven to be very, very important. One is that the transition has to be humane, that it can't be draconian, that it can't be harmful, that you can't have undue effect on certain sectors of society or on certain people's livelihoods. Somebody who is raising alfalfa to feed cattle is going to have to make a transition if you go to a no-meat diet. So, and that involves time. The biggest important part about that humane transition is the time it takes. People will do remarkable things if they're given enough time to do it. When Nelson Mandela came into power in South Africa, he realized that he had to change the mindset around how terrible things were in the immediate present or even in the immediate future. And so he started talking about future building. He started talking about time horizons in which people could imagine change could take place and that they could accommodate the change. And it was very, very transformational. And so I think one part of it is the transition. Another is that most humans don't react very well to being told what to do, to regulatory impositions. They respond much better to incentives. So you have to figure out how to can you incentivize people to behave differently, to consume differently? What kind of incentives might those be? But I think ultimately my answer would be that it's a little bit of a blend of both the regulatory approach and the incentive approach. And the most important regulatory approach in water is to put a lid or a cap on the volume of water that can be taken out of any water source, out of any river, out of any groundwater aquifer, out of any lake. We need to leave enough water in there flowing through those systems so that they protect the natural world, they protect the ecological systems that we all depend upon, as Mark and Guy have asserted. But there needs to be a limit put on how much you can take out of there. Now, the fascinating thing that we've witnessed about places around the world where they have put a cap on how much water can be removed from a particular water source is that it becomes a monstrously powerful driver for efficiency and conservation. And so people learn how to adapt. If they're facing a constraint, if they know there's no more frontier out there, if there's no more horizon, no more abundance of water, we're out of the age of surplus. If they know that there's a fixed limit to how much they're going to be able to take, they will find ways to adjust. And so it becomes a massive driver for the right kinds of behaviors. And part of that incentive also is once you have put a lid on how much can be taken, there still may be plenty of water available for everybody, but they have to be able to share it, and they have to be incentivized to share it. So in any one system of water use, any community that's using a particular aquifer, a particular river, there might be the opportunity to do much more with that available water if people could, when they felt like they had a surplus, they could somehow share it with somebody and be compensated for that. And so we get into some issues about water trading and water markets and systems of governance that allow for water to move among different sectors of water use, different individuals using water. And if we can become both a water conserving and a water sharing society, I think we can overcome a lot of the problems that we're facing with water crises in the world.
Those seem all to be excellent practical suggestions, but there's another issue. And so if you go, for example, as an example, to the area of cancer, President Nixon, more than 40 years ago, declared war against cancer. The war has not been won. It seems from the statistics that cancer is increasing, not decreasing. And you might ask, well, why is that? And I think one of the reasons is that we really don't understand the real basis of cancer and how it occurs and why it occurs. A lot of things are known, and we know a lot about genomics and such, but there's no agreed upon molecular mechanism for what's going on in cancer. And possibly if we really understand it, then we'll be able to do something about it that's seriously effective. So like the area of cancer, the area of other areas of science, in some cases we don't even know what we don't know. And in the case of climate, I think it's the same. I had the pleasure, at one time I was an advisor to the National Science Board, which governs the National Science Foundation. And I sat meeting with all these people, and one person I met, his field was climate, weather, and such. And I asked him about the physics of understanding of what's going on. This was about 8 or 9 years ago, and he said, well, there's nobody studying it anymore. He said, people are now resorting to climate models. Essentially, all the questions, a few of which I mentioned before, people are not addressing. So we don't understand climate, really. We don't understand why in Seattle in the wintertime and in London in the wintertime, you can expect a lot of gray clouds and moisture, and other periods of time it's dry and sunny, except on some occasions. So if we want to do something about climate, the solutions suggested by my colleagues are practical and reasonable and sound certainly interesting. But if we could understand the nature of climate, which we don't understand, it might be possible that we could actually do something about it in a way that nobody has ever expected. And so if I were the president running against our two candidates, I would lose resoundingly if I won. There would be one aspect that I would be eager to fund, would be a fundamental basic understanding of what's climate all about. I think it's critically important to do that, and we don't know, but it might be that if we really understood it, we could come up with practical solutions in a completely different realm of perhaps science and technology.
There are a lot of things we don't know, obviously, and that we will never know. But I think that most people in this room would agree what lies at the root of our myriad predicaments. We know what washes the soil into the ocean at an accelerating rate. We know what fouls the air and dirties the water. We know that the heat engine that is civilization is rooted in civilization. We know that all these predicaments are rooted in industrial civilization. Vote for me. I'll bring it down. It's not a popular outlook. But civilization lies at the root of each of these predicaments, including monetary disparity, endemic racism, endemic misogynism. The list goes on and on. Most of us would prefer civilization to no civilization. And small wonder, we all benefit greatly from the privileges rooted in this set of living arrangements. But the 150 to 200 species we drove to extinction today don't benefit from civilization. I speak on behalf of those who can't speak for themselves.
So, Guy, can I ask you, because I really do like your approach, how do we move to a post-industrial society? I work with a lot of social scientists who look at how society is working and how it doesn't work. And there is all this sort of discussion about postmodernism, moving into the post-industrial society. Do you see any chance that we can move beyond this sort of civilization into a civilization that isn't reliant on the sort of the industrial sort of basis? Can we move forward, do you think?
Not a civilization, but societies are already uncivilized or pre-civilized societies that we haven't made contact with yet, so we haven't destroyed them. The goal is to destroy them. That's one goal of civilization, is to destroy, to incorporate, to absorb every person on the planet. But we haven't done that yet. In the first 2.8 million years of the human experience, the first essentially 195,000 years of our species, Homo sapiens, was spent in pre-civilized or uncivilized societies. There are models. They don't involve 7.4 billion people.
Yeah, and that's a key point, I think, Guy, is there is an issue as to what kind of changes are available to us given the population load that we've got now. So you remind me of a good friend of mine, Kent Redford, who, when he was doing his doctoral research, he was doing it in the Amazon, and he really wanted to go study, some of these tribes that had very little contact. He really wanted to understand. He was, essentially a forest ecologist. I would say more of a ecosystem ecologist. He really wanted to understand how these people interacted with their ecosystems that made them sustainable. And he came away, his doctoral hypothesis of this sort of sustainable community interacting, in a way that was respectful of the availability of resources and never overusing the resources. His findings were very contrary to that, and that, in fact, he wrote a paper that was a very seminal paper, The Empty Forest, which was about the fact that basically the way that these societies were operating is that they would completely deplete the resources in one place, but they had a huge Amazonian forest to keep moving around in. And so it was sort of like patch after patch after patch of consumption and alteration of the forest, but they had enough room to move in. So I think, yes, there are true sustainable use models. I think but I don't know that, all of the sort of Aboriginal indigenous societies necessarily behaved in that way. But the thing that I fear is whether or not we can move to any sort of sustainable alternative post-industrial society, given that we've got 7.4 now billion people on the planet.
Yeah, and one of the predicaments, of course, is human population overshoot. There's 207,000 people on the planet today that weren't here yesterday. And the longer we keep civilization going, the more people we get every day. That's not going to go anywhere good.
I think this is why, I've been very fortunate in my career that I've worked with artists, theatre producers, musicians, looking at different ways to actually communicate with the public. Because one of the things I think that us scientists fail to do is we can really good at problems, okay? We can tell you problems until the cows come home, okay? We are really good at that. What we don't have is the ability to envisage a future that we can aim to move to. So when I ask Guy, what does a post-industrial society look like? It's not because I'm trying to put him on the spot at all. I would love to know what that looked like, because I want to know, how can we have a society of 10 billion people by the middle of this century in a sustainable way? Now, again, what we need to do is actually engage with the creatives in our society to actually provide a vision, because people have a drive, when they see a vision of something that the future could look like, they will happily work towards that. You can see this with young people coming into university. When they see that there's a vision of what they want to actually achieve in life, they'll actually work for it. And I think that's something that our scientists fail to do. Okay? We fail to provide a final vision of, look, the world can be a much better place. This is what it looks like. And I think what is really upsetting is that at the moment, politicians all around the world seem to be stuck in this sort of like fear and threatening mode, whereas politicians used to be able to say, look, if you give me the chance, I'm going to try and make the place better. I'm going to try to actually... And I think that's what we need to get back to. Why have we not got the leaders and actually the artists who are providing a future vision that could be a lot more positive?
So, with all of our great technology, assuming we did have cooperation for a moment, is there carbon-sucking technologies? Are there soil sequestration, tree planting, or other carbon sequestration solutions? I mean, is there someone that says, yeah, there's a way to do it? It would be hard, but we could do it. Does any of this exist? Is it possible to invent?
So I'll kick off. So most of these are then encapsulated in what's called geoengineering, which has some good ideas, some bad ideas, and some completely insane ideas, okay? So I'll start with some of the good ideas. So again, what is really interesting about the 7.4 billion people is at the moment we're using less space than we did 10 years ago. Because people are actually moving into cities, we're urbanizing, people like to be with the big collections of people, and we're actually concentrating. So the wilds are actually becoming more wild, which is a really weird stat to actually get your head around. So again, for me, one of the first things we need to do is to reduce and actually increase forests. So again, we know that if you replant forests in areas, so one of the really beautiful examples is the Loess Plateau. So it's the dust plateau of China at the foothills of the Himalayas. And what happened, this used to be the bread basket for China. For 3,000 years, it was producing food, etc., for the rest of China. But they worked it to death, and it ended up looking like the Dust Bowl of the Midwest in the 1920s, okay? And the Chinese government said, okay, look, scientists, what's gone wrong? What do we need to do? You need to plant trees. So in a slightly more draconian way than we would in a democracy, they went round to every farm and said, right, you are planting tree there, 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 there. If you cut any trees down, you go to prison for 25 years, okay? You know, a nice incentive, okay? But, and a friend of mine documented this over 10 years, planting those trees stabilized the soil. That allowed the soil to actually allow the agricultural goods to grow. But what was also interesting is, of course, trees transpire, so they release water vapor into the atmosphere, made the atmosphere much wetter, and started to stabilize the rainfall. And what happened was this interesting mixture of now wilding of lots of parts of the actual farms and farming, this balance between nature and agriculture works beautifully, and they've recovered that area, which we thought were lost. So if we can recover things like that, then the areas of East Africa that have been deforested, mainly by evil goats, okay, we can actually reforest. And I think there is a lot of work we can do because the space is being given up because people are now urbanizing so much quicker.
And specifically in terms of water, assuming you're the water czar and everyone listens to you and we're going to do what you say, what are the 3 to 5 things that you would like to do and make mandatory? And again, I'd like to refer that Richard Oppenlander was saying that again, that eating animal products is the number one cause of climate change, more than the transportation industry, the number one cause of deforestation, land use, water use. So maybe, I don't know if that's part of your list, but that was number one on his list. So what would you do?
Well, it would be if not number one, then certainly in my top 2 or 3. a meat-eating diet has 3 times the water footprint of a vegetarian diet. I mean, it's just a reality. It's been really interesting in China to watch as the income levels, quality of life has risen in that country. The water footprint of the average Chinese resident has tripled because they're shifting with that higher quality of life, higher income levels, they're shifting to more of a meat-based diet. So we can see these things happening. We see this play out. So diet has an awful lot to do with it. And the vast majority of the water that gets used in the world is going to irrigated agriculture. Stay tuned for my presentation tomorrow. It's about 90% of all the consumption of water in the water-stressed regions of the world goes to irrigated agriculture. And of that, the production of animal feed is a majority share in many places in the world. So if you change diets, you can really have transformational change in the water problem. You alluded, Steve, to sort of technological fixes in that with the water situation. A lot of people, I get asked, probably the most common question I get asked is, isn't this technology of taking the salt out of ocean water, isn't that the silver bullet? It's called desalination. And it is a technology. We can take ocean water and turn it into fresh water. But there are 2 big problems. The biggest of which is that it requires a tremendous amount of electricity, a tremendous amount of energy to do that process. And as a result, that process is extremely expensive. And as a result, that process is creating tremendous increases in carbon emissions to be able to provide a freshwater supply. So, maybe this is part of your heat-generating society guy. So, not to mention that for every gallon of ocean water that you take and turn into fresh water, a half a gallon turns into fresh water, the other half is really concentrated salty brine solution, and you got to figure out some safe way of getting rid of that. So I don't see it as being a silver bullet. Even if we poured billions of dollars into it, I don't think it would be a good thing. But where I would go with the answer, Steve, is that we can create water. Every single one of us can create water, but we don't use it using technology or using some kind of chemistry. We use it by not using the next gallon of water. For every gallon of water that we don't use, it gets to stay in the environment, it gets to stay in the river, it gets to stay in the wetland for the betterment of all of the things that other creatures on the planet that depend upon that, but also by making more water available for somebody else. So whether you're a farmer or running an industrial factory or just operating in your home, every gallon that you save and don't use is a gallon that's available for other purposes. So I call that creating water. And I just think that we have to do 1,000,000 times more of that.
There's also, there are ways that are being developed to reduce the amount of water that's needed to hydrate, for example, plants. And some experiments have shown that certain kinds of waters can hydrate more effectively than other kinds. And some of these waters require relatively minor treatments to produce. And if they can really effectively hydrate cells more than other types of waters, then perhaps the amount of consumption of water that's needed for plants, for agriculture can diminish, leaving over water for other purposes. There are also other kinds of treatments of plants that are under development now. Some people report that plants, for example, exposed to certain magnetic fields or electromagnetic energy can grow more effectively and in healthier ways than plants without them. So, in all of these approaches, there's some optimism for the future that the amount of water per plant can be reduced. And then, in terms of the desalination, good points that you mentioned. So reverse osmosis is the usual way to take ocean water and to produce drinking water out of it. And a few groups, us included, are trying to find ways to do this that don't require enormous amounts of energy. And they're not there yet. There's one group at MIT that has a method under development, and we hope to be successful with our method. And if that happens, then the ocean is certainly another source of water. Granted, the problem of dealing with the high salinity residue that's left over still remains to be dealt with. But there are some technologies under development to solve some of those problems.
Shouldn't we right now go plant 100 billion trees and tell everyone to plant trees? Isn't that always supposed to be a good solution?
So there was an amazing paper in the journal Nature last year, and what they did was estimate how many trees were on the planet and how many were on the planet prior to industrialization. And the numbers came out that there were 6 trillion trees on the planet prior to industrialization. We now have moved to only 3 trillion trees. Okay? So the first thing is that we've halved the number of trees on the planet. But the interesting thing is that all the ecologists were absolutely amazed that there were this number of trees. Because again, as ecologists, we work on small plots, etc. We see a forest. We never actually see the whole of the actual biome that's covering the planet. And so again, what's interesting is I would say there are so many opportunities, particularly now that people are moving into the urban area, to rewild. And this has become an interesting debate, and actually to start to replant. Now, the debate then, however, is what sort of trees do you replant? Do you replace what was previously there? Or do you say, hang on, I know climate has changed and is changing. Do I plant trees that are more appropriate now for the climate and the water stress that's going to occur in this area? And that's a really emotive issue because, again, you're starting to get different trees in locations that you never expected them. And also, we have no idea what's going to happen to what's now called novel ecologies because you're mixing plants that haven't been mixed before.
Guy, would that make a difference in any way in if you planted 100 billion trees?
One of Derek Jensen's conclusions about civilization is summarized in just a few words. Forests greet us and deserts dog our heels. Those 6 trillion trees were big. The 3 trillion trees are small. The old growth is gone for all practical purposes. So we have 3 trillion toothpicks, but that's not nearly as much carbon as was found in the 6 trillion trees. And the ecosystems in the wake of the deforestation of the 6 trillion is absolutely devastating. Do I think it would make a difference to secure some carbon in trees temporarily? Remember, they die. Sure, temporarily, but it's a temporary fix and it requires an enormous amount of energy. And we're running out of fossil energy, or not really running out so much as hitting the peak of the extractable energy. So it takes an enormous amount of energy, and that's yet another means of maintaining the heat engine that is civilization. I hate to keep bringing that up, but it just seems to keep coming up. Sorry about that.
The going consensus among everyone is that we should rapidly move to solar, wind, geothermal, and other sustainable alternative energies. I understand you're saying that it takes a certain amount of energy to produce and install that solar or wind, but at some point it seems like it would be net positive. So when I advise people, if someone says, what should you do? I mean, I always think, oh, that's great. We're adding more solar. That's a really positive development. Am I wrong? I mean, should I be encouraged that we're, when I hear that Germany is becoming more solar and wind oriented, is this still a goal that's worth pursuing to transition as much of our fossil fuels to these sustainable sources?
Well, we don't know even what causes the wind. It's not so clear, really. People talk about pressure differences, but pressure differences between intense storms and the fairest of weather, just a few percent, and it's not so clear that that's responsible. Another idea is that charge gradients produce the wind. And so if you interrupt that by capturing some of the energy in these machines, it's not so clear, it's not so clearly predictable what impact that itself would have on the environment, because nobody's thought of it and nobody's studied it. So, it seems that almost anything you do has a positive aspect, but along with it is some negative or questionable aspect. And this is something to take into account, that these alternative methodologies are not without their effects as well. So it's not so clear whether that will solve the problem, although it seems that it's going to help.
So the interesting thing is, of course, if you have a solar panel factory covered with solar panels, you can then start to undo this fossil fuel reliance. So again, it's about the means of production. How do you get the energy to produce the goods that you want? And so I think this is something we need to start thinking about, how you actually do that. And also, there are interesting incentives. So again, one of the things that would be absolutely brilliant if scientists could invent is a little additive to make concrete. The problem with concrete is you need to heat it up to about 1,500 degrees Celsius to actually make it into concrete. Okay? And concrete, we know, builds everything around the world. So you can only get that heat by gas burners. Okay? So you have these huge gas burners that heat up the aggregate to make concrete. If you could find a magic additive that allowed the concrete to form at a lower temperature, below 1,000 degrees, then you can do it with electricity. Electricity you can get from green sources if you want to, and therefore you could green cement making. So again, it's then trying to find these incentives. Now, people around the world are desperately trying to find that, because if you find that additive and you patent it, you are going to be made for life. So again, there are lots of things about our technology that slight nudges will make a huge difference.
That reminds me of energy from the environment, something that actually Tesla was dealing with, and other people have actually extracted. So there's actually a vertical gradient of electric field. Most people don't know about this, but in Russia, for example, it's common knowledge. There's an electric field, not magnetic field, but electric field that runs perpendicular to the surface of the Earth, from the atmosphere to the surface of the Earth. It's 100 volts per meter at the surface of the Earth. It means if you're standing up, it means your nose is 200 volts more positive than your toes if you're 2 meters tall. And people have actually extracted energy from that. This is energy that's available and freely tappable. So some people have put a balloon up in the atmosphere and put one electrode in that balloon and the other at the Earth. And if you have a long enough wire, you can actually run motors from the potential difference between up high and the Earth. It's thousands of volts that can demonstrably run motors. And this hasn't been, this was of great interest 100 years ago, but people have lost interest in this for some reason. So this is one of many possible realms of energy that is available, but not really getting used very much. And another one is in the area of water. What we've been studying is this phase of water that's an interfacial phase that forms when water meets hydrophilic surfaces. These are negatively charged, and the region beyond the region of water is positively charged, so it's like a battery. And we found that the energy required for building or charging this battery comes from energy freely available, mostly in the infrared region, energy from the environment. So this is yet another means of capturing energy from the environment. Freely available, you might call it literally free energy, because it's always there, using this to build a potential difference, electrical potential difference in water in the right circumstance, and actually using that potential difference to get energy. So these are methodologies which could help the situation by providing energy in ways that you might call unconventional.
I guess I'm a little perplexed by this seemingly overwhelming desire to maintain this omnicidal set of living arrangements. We drive to extinction 150 to 200 species a day, according to the United Nations report from August 2010. We foul the air and spoil the water. We kill brown people so we can have oil for another week. And yet all we can talk about is how are we going to keep this going? How are we going to keep this going? How can we make more concrete so we can keep this going? How are we going to have more water so we can make more babies so we can keep this going? I don't get it.
Well, assume that you had full reign. What are you recommending that we would do? And how ideally should we move forward, or what could we do?
I already mentioned it. We know what the root of all our predicaments is. Get rid of the root. Go to the root.
So how
Terminate civilization. How? There are at least 2 relevant recent books. The one I recommend is called Underminers by Keith Farnish. It's at underminers.org, and it's free. And there are thousands of strategies dealing from the incredibly easy and low-risk approach of writing letters to the editor and letters to your congressional representatives to taking direct action that might get you thrown in jail.
We'll assume we don't want anyone to go to jail, and we wanted to make good things. I mean, we could tell people to live off wild edible weeds, but what concrete things could we do to transition to a sustainable way, even if it meant giving up our comforts? Could we live on wild edible weeds? Could we build huts? What are you saying is if we were willing to do it, what would be a sustainable way to live, even if people were willing to give up their niceties? What could we do?
There's an ecologist named Paul Czafurka who several years ago calculated the human carrying capacity of the planet now that we have stripped away the soil and contaminated the water and so on. And he came up with a figure of 35 million with an M, plus or minus 15 million. That's the number of people that the planet can sustain, given today's planet that civilization has effectively destroyed. And now he concludes that the number is 0. But 4 or 5 years ago, he thought it was 35 million. How did we get there? Only by getting rid of civilization through the myriad techniques that Keith Farnish and Derek Jensen and long before them, Dave Foreman and Edward Abbey recommended as strategies for terminating civilization. I'm not going to go into all of them here, but the notion that we shouldn't risk going to jail, but that it's perfectly normal to kill people from other countries to sustain this unsustainable set of living arrangements. I must say that requires some audacity all by itself.
But I guess we don't want to kill anyone. We don't want to go to jail. We want to find solutions that allow us to live closer to the way we lived hundreds of years ago and live off sustainable food, if that means wild edible weeds. And
No, I think we're in danger of romanticizing the past and saying, oh, everything was so much better in the past when there were so much fewer people and actually sort of it was all so much better. Okay, I mean, admittedly, we didn't have vaccinations and actually 6 out of 8 of my children died. But don't worry, we were living sustainably and it was much better. I'm sorry, I really like civilization. Okay, I really like the fact that humans can live in collective cities. I mean, think about it. Humans are amazing creatures. We can live in a city of 10 million, okay? And the level of violence, I know it's slightly higher in the United States, the actual level of violence that we encounter on a daily basis is almost 0, okay? If you look at any of the other animals, such as chimpanzees can't actually go an hour without punching each other, okay? So we are a highly evolved, ultra-social creature. We're the only one that exists, that can exist in cities of tens of millions and operate and function, okay? So therefore, okay, it's a challenge that we then have to look at how do we organize 10 billion people? How do we actually organize to make sure that the resources are there? But think about it. The sun has unlimited energy, okay? It's going to keep going for another 5 billion years, okay? We're never going to use it up, okay? So we can harness that. We have resources. We can recycle resources. The infinite ability of humans to adapt and to actually make new things is clearly our wonderful sort of design, okay? So therefore, I'm sorry, society isn't great. I'm sorry, you're absolutely right. We shouldn't be killing other people. There shouldn't be racism. We shouldn't be sexist, okay? However, we have moved so far forward from where we were. We need to keep moving forward. We need to actually have a way of actually changing society. Because again, if we have a vision of a society with a balanced 10 billion people on the planet, whereby we have agriculture, which is vegetation-based and not meat-based and things like that, we can actually do this, okay? And yes, I agree, we shouldn't be pushing all these species to extinction, and we need to be able to work out how we can actually live and steward this planet without killing all these people. But I think that we need to reduce the population from 10 billion down to 35 million. Seems to be a defeatist approach. I think that actually we are so much better than that. We are humans, and we are the most creative species that we've ever met.
I don't want to romanticize the past either, and I sure as hell don't want to romanticize the future. How many people have to die so we can keep the lights on? That's what it takes. We can't have the lights on in here unless we kill brown people in Africa, period. But we're not going to give that up. We're going to look the other way. Africa's and the Middle East, that's where the oil is. That's the master material. That's how we get everything else. That's how we maintain the electrical grid. That's how we build the solar panels. That's how we get the coal out of the ground.
But if you actually look at the numbers, okay, we're fed daily with all these numbers about the conflicts and things like that. If you actually look at the total number of people killed in conflicts, they have dropped markedly since the 1960s, okay? The amount of violence that occurs in the United States started to drop and has dropped every single year since 1985. In the UK, violence has stopped, peaked in 1990 and has started, and it doesn't matter what we do with the police, increase, decrease, etc. Every year, violence is actually dropping. So if you start to actually look at some of the actual figures of people that have collated things, things are getting better. More people are actually getting food. Less people in total are starving every year. Now, of course, it's not quick enough, and it's not good enough, and we still have to do much better. But again, it's not this defeatism that's like, oh, it's all terrible, we should basically just give up. I'm sorry. Again, there are so many good things that are happening in the world. We need to actually encourage that and accelerate it. And again, sustainability is one of those things that we can really get behind. We can actually deal with climate change. Perhaps I'm too optimistic. But hey, we're humanity. We can do this.
Let me try to stake out a little bit of a more moderate position between the two poles that are on my left and right. I'm not sure that, to Guy's point, I'm not sure that we want to just acquiesce to the fact that our global population is going to grow to 10 billion. I don't see any advantages to that. I don't see any advantages to further population growth. And I certainly see a lot of advantages to stabilizing growth and to reducing it by humane means. Again, you heard me say before, it's all about the transition and about how you treat people with dignity and respect in the meantime. But I do see, Mark, a lot of, to your point, I think there are a lot of things that have gotten better, but I think Guy and I, being trained in, biodiversity conservation, we see a lot of things getting really quite a bit worse in a hurry. Here's a statistic for you. The populations of freshwater species on this planet have declined by 76% since 1970. That suggests to me that maybe we're a little bit too many of us here. Maybe the demands that we're placing on water, the way that we're altering water systems to generate electricity. Mark, I take your point that maybe we could have the capacity someday to be able to sustain a greater population, maybe even a population of 9 or 10 billion. But I fear that our rate of adaptation, our rate of learning to make our world, to learn how to make our world less damaging, or the way that we garner our resources less damaging, I don't think we're learning fast enough to prevent a lot more disastrous things from happening at the pace that we're heading for 9 or 10. So I'd much rather talk about how do we keep it at 7, or how do we drop it down to 5, but again, doing it through, not through militaristic means, or doing it through genocidal means, but rather doing it through very humane means. And in that respect, I think about when I was, again, in high school, the number one environmental issue that we talked about in 1970 was population. And that discussion seems to have fallen off the radar screen. I don't hear anybody, even in the environmental community, talking about population and the need to do something about stemming the growth of our population. And I have a lot of understanding as to why that came about, but I don't know why that discussion has even fallen out of the environmental community now.
I think it particularly fell out in the United States. And again, I've been very lucky to work with medics who have been investigating population growth and things like that. And the key thing was actually it was under George Bush with the gag law. So it meant that no funding actually went into the UN that had anything to do with family planning.
Right.
And that caused a real problem. Now, for me, what has been the outcome of studying population dynamics all around the world is one of the key things, the most important thing to actually control population is actually women's education.
Right.
And it's really interesting that as soon as you can get a women's population educated up to secondary school level, they take control of fertility, and then you find that the fertility rate drops off markedly, and you stabilize populations. And you can see that and it doesn't matter about religion, it doesn't actually matter about culture. As soon as you do that, you get that sort of drop off. And that's the problem. I agree completely. Yes, if we can engage with family planning programs and engage with women and educate them all across the world, then you're right, we can get it much lower. Now, the interesting thing about the predictions are they sort of like peak at 2050 at about 9.5. Okay, it depends. Okay, there's a huge error bar. And luckily my error bars are slightly smaller. But then actually, they drop off by the end of the century. Now the problem is, how do we move that down? And that is a real problem.
I'm not sure. The last time I looked at the population curves, they suggested otherwise, Mark.
Okay.
20 years ago, I had a friend of mine ask me why, knowing what I know about the deterioration of the natural world, how could I still be optimistic? And I said, in my mind's eye, I had that population curve that we grew up with in the 70s and the 80s, and it flattened out. Back then, they were having it flatten around 7. Even a little while later, it was flattening out at 8 or 9, but at least it was flattening out. And I said, the reason I can be optimistic is my job in my lifetime is to try to lose as few of the parts, to have as few species go extinct, until we can get to that plateau. That's my job. I own that task. But then when I started to see the recent UN population curves, they don't go flat. And that really disturbs me, because now I don't know what my job is.
So it's your fault. I was just looking for somebody to blame. And here he is, ladies and gentlemen.
I have to own my share of it.
You really wish you'd stayed at home. Now you're blamed for population growth.
Well, I certainly haven't done my share to try to do something about it.
Yeah, I was teaching the importance
Although I haven't had children.
I was teaching the importance of educating girls and women so they wouldn't have children 25 years ago, when there were approximately half the number of people on the planet there are today. That worked great. It's just a fact. We keep pounding the same drum, and the outcome remains the same, and we keep expecting it to change. And I think that's a definition of insanity, if I'm keeping track.
Should we immediately close nuclear power plants while we still have water and electricity and the ability to tame them? Guy, you had mentioned that if we did have lack of power or lack of water, then these nuclear power plants or the rods would create very significant problems. So should we, right now, while we do have water and stability, try to close them immediately?
I think so, absolutely. If I was dictator for a day while I was terminating civilization, I would be working really hard to decommission the nuclear power facilities. There are more than 400 around the world. There are more than 1,200 ponds with spent fuel rods, and it takes 50 to 100 years to decommission each one once the money becomes available. And we haven't started yet. There's a lot of money in commissioning them, money for private corporations. There's no money for decommissioning, so we haven't started that process yet. And that's a long-term proposition.
Yeah, Steve, I will say that there are individuals within the environmental community who would argue that we need to sustain nuclear production for some next few decades as part of the transition to getting to the point where renewable energy is up to the point where it can sort of fill the gap. But there are some who will argue that if it could displace other more damaging ways of generating energy, that it would play a role. I think you have to counterbalance that logic with the fact that mistakes do still get made. And it's very recent that we had some pretty bad accidents with nuclear facilities around the world. And so it's not perfect, and I'm not convinced that we can do it in a safe way. And to Guy's point, we haven't figured out what to do with safe storage of the waste. So I'm not in favor of it myself.
I'm with Guy.
We might want to write that down.
We all agree on something.
I think it's
Or at least
exactly
three of us.
9:15:27. And Mark and that guy agreed on something. Are you writing this down?
Should we stop exporting food that takes water? Are we, in effect, taking our good groundwater and giving it away because we grow apples here with water and then we sell the apple? In a way, are we selling our water to other countries that we need?
Who's we?
The United States?
Yes and no is my answer. We should not continue to export food that's being grown unsustainably with respect to water. So if we are what we call mining groundwater aquifers, taking more out of the groundwater aquifers than is being naturally replenished, that's unsustainable. We can't keep doing that for very long. And we're getting to the point where in places like the Ogallala Aquifer in the central Midwest, where farmers are no longer able to pump water because it's gotten to be so deep and it takes so much electricity to pull it up to the ground, and that costs so much that they can't afford to farm anymore. So we should not be exporting food if we're growing it in that manner. If we're using water in a sustainable manner, there's an argument to be made that it can really help to sort of water subsidize countries that don't have as much water available and the ability to grow food to subsidize their populations. And I think it's a valid argument. I'm not for drawing the fences around nationalism and saying that we shouldn't be exporting any food. I think there's a lot of good economic reasons, and there's a lot of good sort of moral and human reasons why we should continue to export food to help other countries and other populations that can't afford or that can't, because of their water availability, not produce as much food as they need. But I don't think we should be doing any of this in an unsustainable manner.
How much of the world's food is currently being watered or grown with aquifers that will be dried up in the next 20 years? And is there anything to learn? So that's question one. How much of the world's food is grown with aquifers that will be dried up in the next 20 years? And is there anything to learn about water from Israel or any other countries that have been successful with water, with water management?
I guess
It's you again.
I know this one pretty well. So something between 10 and 20% of our food is being produced on aquifers that are declining, aquifer levels are dropping. Again, it's like a bank account. If there's not enough water being infiltrating, percolating back into those aquifers to replenish them, as compared to the rate that we're pulling them out, then the bank account, the water account goes dry. Steve, to say that they dry up is really hard to determine, and it's not. The problem doesn't become when the aquifer goes dry. The problem becomes when the water level gets so far down that it becomes uneconomical to extract it. So that's sort of the extinction of an aquifer in economic terms. And that's the part that we have to be really concerned about. There was another part to your question, though.
Is there anything
Israel, yes. So the Israelis have done some really miraculous things with water. And if I had to pick one country in the world that I would give the blue ribbon to, I think it would be Israel. For a couple of reasons. There are some big caveats. Wait for it. They've done some really incredible things. They are as efficient and as conservative with water as any society on the planet. A guy named Seth Siegel wrote a wonderful book about the Israel water situation. He documents a lot of the things that they've done, but on a per capita basis, they use less water, or they're as conservative with water as any advanced, developed nation on the planet. They have learned how to become very efficient in their growing of food as well. They have accomplished all of this in part because it's a wealthy society, though. So this is part of the caveat. A good portion of Israel's water supply, and particularly in the cities now, comes from desalination. And we talked about this just a little while ago. Desalination is very expensive, so the fact that it's a wealthy society enables them to pay the cost of desalinated water. I think the Israelis are doing a pretty good job with the brine solution, the disposal of the brine solution out in the ocean, but it's a very expensive technology, and they aren't doing it entirely on renewables, they aren't doing it entirely on solar energy, and therefore they are causing some carbon emissions to a greater extent than if they were supplying their water in other ways. Another big caveat, and this is the one that I've really challenged Seth on in his book, a lot of the Israeli water community wants to claim success. They're the first country to be water sustainable for the foreseeable future, but I point at the fact that their primary natural water source is the Jordan River. The Jordan River headwaters above the Sea of Galilee. It then flows downstream and enters into the Dead Sea, which is kind of a dead end for all that water. Well, they've almost completely dried up the Jordan River. Not just the Israelis, but also the Jordanians and the Palestinians. They've all had their share, but the Israelis take most of the water. And they have dried up that river. The only water that trickles down the Jordan River, and this is a holy river where John the Baptist, first was baptizing, his spiritual followers. The only water that still remains in the Jordan River is water that is wastewater from irrigated agriculture. It seeps back into the river, so it's got a little tiny trickle of really putrid, polluted agricultural runoff water. That's all the water that flows down the Jordan River. Because the Jordan River no longer flows into the Dead Sea is dropping in water level by 1 meter per year. Now, just at face value, that's a striking number, but when you see the topography around the Dead Sea, it's very, very gradual. It's very flat. And so when you drop 1 meter, it means that the edge, the lake level, is receding by on the order of 1 kilometer or multiple kilometers every year. And so all these farms, villages, resorts, what have you, that used to be right at the perimeter of the Dead Sea now are left stranded. They're like kilometers away from the water level in the Dead Sea. So I'd give them the blue ribbon, but they've got a pretty big bad spot, on that blue ribbon. But they're as close as any society, any nation at least, has gotten to become to doing all the right things. But they haven't completely solved their equation, and I won't give them the sustainable title until they can deal with the carbon emissions associated with their desalination plants and with bringing the Jordan River back and the Dead Sea back to life.
If each
How's
of,
that?
thank you. If each of you would make a final closing statement on anything that you think is appropriate or relevant to say to conclude our panel tonight.
Let me start here. Just in a comment on the Israelis. I know that they were the ones to invent the drip irrigation method, and that was a tremendous advance. I've had some dealings with one of the companies that is very important in desalination industry around the world. And they're working desperately to increase the efficiency of the reverse osmosis process that they use. They haven't gotten there, but they certainly have got their head in the right place. And so I guess my closing statement is being in my expertise is in a realm that's outside the realm of all of the rest of you. And I would just like to make the final point that I think the science that is surrounding all of many of the things we talked about is uncertain, and the science of understanding of climate is, I think, critically important because it presents an opportunity for us to do something about this that's not in a political realm, not in an economic realm, but in a scientific realm. And we won't know what we can do until we understand the phenomena that are occurring. So I would say that one important feature that's not discussed a whole lot is to really understand deeply and fundamentally basically the underlying forces that govern the climate. And if we know those, and we know them well, then perhaps there's something that we can do to ameliorate the problems that we obviously face.
So, if I look at this century, we have 4 major challenges. We have climate change, we have global poverty, we have environmental degradation, and we have global security. And so what we need to do is, as we did in the middle of the 20th century, is reinvent our nations and our international policies and how we interact with each other to actually see how we can build win-win solutions, so when we actually try to solve one of the problems, we don't actually make any of the others worse, but actually perhaps improve them. And for me, that's going to be the key. The key to these problems is actually governance. It's how we run our societies and how we actually work collectively together. So for me, what's the most important thing is not necessarily the science underlying these things, though we can help, we can advise, is actually how we govern our societies and how these problems are going to be addressed and into the future. And again, as I said, I'm an optimist. I can see that these things can actually be addressed, and we have the technology. We just need the systems and the policies to allow us to actually deal with these things.
My conclusion is that all of you must be really depressed. And we don't want to leave you that way. Well, at least I don't want to leave you that way. You've still got one more person here for concluding statements. Yes, yes. What I want to leave you with is, at least for the near-term future, we really can get out of the water crisis, and many of the water crises that exist around the world, and we can do it in an affordable way. Governance will help a great deal with this. Other incentives will help a great deal, but it just means learning to do a lot more with a lot less water. And tomorrow in my presentation, I'll tell you stories about places and people around the world that are doing just that. This isn't like dreamland. This is a reality. We can do this. We just have to do it at the right scale. Everybody has to be doing it. And I'll leave you with one statistic to illustrate that. If we could just reduce the amount of water being consumed in irrigated agriculture by 20%, we could resolve the water shortages that are happening in most of the water-stressed regions of the world, and we could bring many of our freshwater ecosystems back to life, back to health. And so I think those are the kinds of things that we really ought to be focusing on in the next couple of decades.
And now for the silver lining.
Mr. Cheerful.
Soviet scientists termed this epoch the Anthropocene about 50 years ago, in the 1960s. And an American ecologist tagged it the Anthropocene in the early 1980s. And the term has become fairly broadly known since then. I think that we're in the age of consequences. I think that the Anthropocene is coming to an end, and that the current epoch should be called the Indocene. And the silver lining is that the odds against any one of us being here exceed the odds against plucking a single atom from the entire universe at random. We know about DNA. We know how many atoms there are in the universe, believe it or not. It's essentially impossible that we get to be here, but here we are. As evolutionary biologist Richard Dawkins says, in the teeth of these stupefying odds, it is you and I that are privileged to be here, privileged with eyes to see where we are and brains to wonder why. It's pretty amazing. So I'm heartened, I am stunned, I am grateful that we get to be here and that we get to be here now. And on behalf of all of us, I want to thank Steve for putting together this entire conference and the panel.